Howdy, and welcome to Broken Tool Garage. This video is going to be a little bit different. This is going to be a response video to New Guy's Garage What Size Carburetor video. And that was a really good video. If you haven't watched it yet, head on over there. Check that out. Carb right there for you. So what could I possibly add to that? Since it's a great video, well, let's just take a peek at this 360 right here and my experience with it in different size carburetors. The engine is a Mopar small block 360. It's been bored 30 over, Keith Black 9.8 compression ratio pistons in it, right? So the heads are 360J heads, which are pretty much the same things as the 340J head, but it's got a 188 intake valve instead of a 202, and then the same 160 exhaust valve, right? They've been gone through just a home port that I did, which is just a general cleanup, or like a first cut if you watch the professional cylinder head porters, right? Maybe it's as good as their first cut. So stock rockers on there, non-adjustable. Camshaft is a Mopar 508 camshaft. Specs are there. Air gap intake manifold, 600 CFM carburetor, MSD box, and the MSD coil to go along with it, 8mm spark plug wires, stock distributor. That combo there, 600 CFM metal block, did pretty good on street. Got up to speed pretty good, your interstate, 60 mile an hour speed, 65, whatever. No issues, good gas mileage, ran great. Actually, I think with a different cam in there, I had a comp cam at the time, 600 Edelbrock. Did a road trip and I was getting like 18 miles a gallon with a 355 gear 904 automatic transmission, which is the little 3-speed non-overdrive, right? Did pretty good little combo. However, whenever I took it to the drag strip and I started doing more of the higher RPM and racing scenario, it didn't quite cut the mustard. So I had a 750. Put that on there, that solved the problem. So by not cut the mustard, let's define that a little better. That's a little vague, right? I couldn't really go much past about 95 miles an hour. Of course, that's on street, so why would you ever want to go faster than 90 miles an hour, right? So that's about 4,500 RPM with the tire size that I had on the truck at the time. It just really laid down and didn't do much. Put the 750 on there. That woke it up on that part of the power band. Of note, the 750 actually drove around fine. I didn't have any bogging or odd things right there. What I would do when I went to the track, I would put the 750 on there. And I can't remember if I put a 4-hole spacer on the 600 or the 750. I can't remember that. It's been too long ago. Which spacers are a whole nother subject there. But that's the experience that I had. The 750 was apparently not too big. I gained performance on the upper end, but I didn't really lose anything that I noticed on the lower end either. So that seemed to be a little bit better fit. The 600, driving around, doing pretty much anything under 4,500 RPM, perfectly fine too. So that leads me to a conclusion that as long as you're, trying to figure out how to say this, your carburetor size isn't you need this exact specific CFM carburetor for it to even function. You got a lot of wiggle room in there. So sure, I could go too big. That 750 on a stock 318 it would be too big, right? My combo here worked pretty good. Okay, let's talk about a couple different carburetor types. New Guy's Garage did mechanical secondaries. So let's look at what a mechanical secondary would look like, right? So we got our throttle plates in here. This is the primary. When they open so much, you see the secondaries open, so primaries, secondaries. They're mechanically linked. They will open when you open the throttle. A vacuum secondary, see it opening? Opens all the way. Doesn't do anything. Not hooked to an engine that has a vacuum source. So whenever these are open, not sure if you can hear that. You can hear the vacuum pod operating. Has to have vacuum on it. So Edelbrock, what they did, and I showed you Edelbrock as an example as a mechanical secondary. Not exactly true, but you get the point there. What they have is what they call an air valve. Right? See that? All right, we're going to do that number. Now you can see the light. So now you can see how that works. Once there's enough airflow around that leakage area, this will start to open up and it'll allow air to go around the booster and start pulling fuel in. So that is non-adjustable on Edelbrocks until you get the AVS2 carburetor. And what we can see back here, the internal air flap, like what we were seeing, is gone, and you have this one with a spring attached to it and an adjustment, so you can dial that in. See my corroded spring there? So the Edelbrock carburetor is what I am used to right here. This is where my experience is tuning these and running these on street and some race. They're pretty simple. That's why I like them. Usually, like actually this one right here, the AVS2, I literally took this carburetor, put it on my stock 360. This is a 650 CFM carburetor. Put on my stock 360 out of the 88 Dodge truck. Went in and warmed the truck up, set my idle mixture screws, come back and set my idle speed, then come back and set my idle mixture screws again. That's it, 3 screws. Put it on there, drove around the block a little bit, made sure it's good and warm, and then just put it right straight to the floor. This didn't fart, didn't sputter, didn't do nothing but spin the tire because, Dodge truck, it's open rear end, and had no problems out of it whatsoever. That's what I like about these. Super simple. Okay, I'm going to expound a little bit on boosters. So why would Edelbrock have such a thing like that in there? Here's your booster. You got air coming in, right? So it's coming in around here, going through. You have some air that's trying to go around this booster. So this booster, if you look at that, that's got a 45-degree cut in it, see? So as the air comes through the center circle, right, it's got to come around and go through there and speed up so that it starts drawing the fuel out. So the fuel path on that is, if we look here, it's got to come up through here, which comes over, and then the jet right there, there's the fuel bowl, so the jet is right there. So it's got to draw it all the way up and into the booster. What the booster should be doing, if it has enough air speed, air pressure, actually it's CFM, it's your mass airflow. And we've all heard of mass airflow meters, right? So the mass airflow has to be enough to draw that out in sufficient amounts that it don't just kind of dribble out. It comes out and it vaporizes. That is what a booster is supposed to do. So what I think Edelbrock did with this, they figured out that if you have this on here, and you can see where the air can come around, right? I showed you that before. You can see where the air can come around. Until there's enough mass airflow, which the mass of the air actually is pushing it down, because this has mass, right? And I'm pushing down on it with force. Actually, if we had something with enough gravity, it would just open it. Same idea. Until it has enough, they know that this booster won't work right. That's my theory on that right there. All right, so that's a little bit of difference between the mechanical carburetor and the vacuum carburetor. I guess Edelbrock's a vacuum carburetor. Not a very good term in my opinion, but that's my opinion. The vacuum operated carburetors, given they have that cushion in there, if your carburetor ends up being a little big or something like that, it's more forgiving on that. The mechanicals, like what New Guys Garage said, will work better if you get them sized right and tuned right. That's the tricky part right there. It's kind of like me. I'm do Edelbrocks. I know those because they're simple. When I'm moving over to this Holly style carburetor, there's a lot more adjustments on it. So that's a more advanced carburetor in my opinion, because there's more adjustments. That means I can do more with that carburetor and get my tune set a little better. A little bitter. All right, let's move to some calculations. All right, here is some calculations. This is the 3456, and it's my fourth attempt at recording the right screen and the right window. All right, so we see here is Summit's little calculator. I'm sure we've all used this at some point in time, just to see how much carburetor we need. So there we go. Street carb right there, for my 360, and racing carb right there. This is based on 85% and 110% volumetric efficiency, like what we can see right here, right? So I've just calculated that. I got my cubic inches, I got the RPM in there, plugged in the volumetric efficiency, and the constant right there. So I can change these values, I can change that value, and so I'm not stuck with just 85 or 110. Not like I know what the volumetric efficiency on the engine is anyway. So if we look at our number here, right, 538, right there, and I had trouble with a 600 CFM carburetor. And they're saying I need a 538 or 550 be the next one would work perfectly fine. I also don't think that I have 110% volumetric efficiency, which would seem to be a lot closer because that would be a 700 CFM carburetor and I had a 750. Not quite sure that's the best way to go about it on certain applications. If we look at stock, or close to stock, I think that would be pretty close. That would get you in the ballpark. But it's kind of like what I was saying before. Your vacuum secondary carburetors, and everything, you don't have to have exactly this specific size carburetor for it to function right. So the kind of my experience that I just showed you tells that right there. All right, here's something cool. So this is the same thing, but broken down into 500 RPM, 1,000, and so on and so on and so on the graphs right there. So this is all this is doing. It's saying, hey, you have 365 cubic inches of engine. It cycles that 365 cubic inches over 2 RPMs because we're four-stroke engine, right? Then multiply that by however many RPMs you're turning. That gives you your CFM, right? You can see equation up in there, conversion factors, all that good stuff. So we come out, same thing we're doing over here. What is cool, if you look at this, as RPM increases, the CFM, the engine slash air pump, because that's essentially how I'm math modeling this, is as an air pump, it can pull more. Now that's how much the engine is pulling by itself, just what you can do if you disregarded anything with the exhaust events, trying to think of the name of how the air rams into the intake, and you can get your slugs in there, and intake pulse timings, and all those things can make you more volumetric efficient. This is my 100 column right there. They didn't label it like that, but I think we get the point across there because all these numbers go lower. So that gets into a lot of theory there. Here's a pretty good little article on motor trend that you can look at right in here. That's super cool. I keep forgetting you can't see my mouse pointer whenever I'm recording the screen, so I hope you kind of read between the lines on that one. Okay, let's go over vacuum at wide open throttle. That's well, I guess kind of controversial because, well, first off, people have to actually measure it, and you have to measure it accurately. So that's the two things there. So what I'm talking about is whenever you have your throttle all the way open, right, and you're at maximum RPM, what is the vacuum in your intake manifold during that time? Because that comes right back into how much pull you have on your booster, right? So if I'm trying to say this right, you have atmospheric air up here, and you have the engine creating a vacuum down there. If that's not equalized, then you have the engine pulling vacuum that's not being fully utilized, right? So if you have, say, just going to throw a number, 10 inches of vacuum, right? Then that is essentially 10 inches of vacuum, not pressure, but like a pressure, that is not being used to draw air through the carburetor. However, 0, you would think would be pretty good, but if you're at 0 vacuum, then, like it's pulling all that it can pull, it can't pull any more without boost, then what are you doing in your booster area right here? Do you have enough vacuum depression in here to take those fuel droplets and basically make sure they vaporize? So on fuel vaporization, think of it like your air conditioning system where you have high pressure over on this side and low pressure over here on this side. What is in between that? Of course, there's several ways to do it. You can do like an orifice tube plate, or you can do expansion valves. There's another technique, I forgot what it was, where you just got a coil of wire, a real thin wire that you can use. But every one of those is doing one thing. You have high pressure liquid on one side, and then it goes through a small hole, right, on the other side. Whenever that high pressure comes through and it goes to the low pressure side over here, which vacuum is low pressure, even if it's atmosphere, vacuum's low pressure, right? The lower the pressure that is, whenever that fuel comes out, the more it's going to want to just atomize and turn into gas. That's what it's trying to do, so that gives you better atomization the more vacuum signal you have down on the bottom. But the more vacuum signal you have on the bottom, the more potential airflow that you have that you're not utilizing. So it's that balance in there. That's why it's hard to say, this carburetor is perfect for your application. Well, a lot of things go into that to try to determine that number right there. So that's going over vacuum at wide open throttle. Here is what I want to do. Got the 360 over there, right? I have my 650 CFM carburetor, and I have a 750 CFM carburetor, and actually I was thinking I even have a 600 CFM carburetor. Of course, that one need to be cleaned up and everything. These two are ready to run. What I can do on the ram charger when I get it up and running is do exactly what I'm saying. Hook the vacuum line up to it, and then like that chart that I showed you, at this many RPM wide open throttle, I have this much vacuum. Step it forward, do the test a couple times to make sure it's repeatable for each one of these carburetors. That's what I can do on a real world test out not even having to go into the drag strip or anything. Go down the highway and do that, right? So let's get into some test methods. That's one of them right there. If you really want to dial your carburetor in, you can kind of do what I'm talking about there. Also do like 8th mile test, 0 to 60 test. That's something you can do in your local area, because pretty much all of us is 0 to 60. You got at least a 55-mile-an-hour highway around you, right? So you can at least do that pretty safe. That's a 0 to 60. 8th mile gets a little, the faster your car is, the more likelihood you're going to exceed the speed limit quite a bit when you do your 8th mile test. But that's kind of a test idea there. Go in, check your times. You can use the Draggy. You can use the, I like using Track Addict myself. Use that as a tool. Do it several times to see if you get repeatable results for a given combination. Record your time. It'd be really good if you had the weight of the vehicle added in there, because if you have a 8 mile time and you got a weight, especially if you even have a mile per hour in with that too, you know your horsepower pretty much, right? You can calculate that. So you can go in and play around with that stuff right there, gathering that data for each one of your carburetors. If you really want to be thorough, you can start out with 500 CFM, 550 CFM, 600, and so on and so on and so on, until you reach too big of a carburetor to where you're not getting any more power, or yes, you gain power, but you're starting to really lose all that driving around and trying to get up to that maximum RPM. All right, hope that made some sense right there. So that's a little bit of test methods that you can do if you really want to get into it. It doesn't matter what calculation you use. It doesn't matter who says this or that. Unless they have your specific combination, they're not going to get you the right size carburetor. And again, I can put any of these carburetors on that 360 and drive around and be perfectly fine. Going to the drag strip, completely different scenario right there. Okay, let's summarize this up just a little bit. What size carburetor do you need for your application? Well, kind of an open-ended question. You need more information, and there's not just one carburetor that will work perfectly fine. You got a range of carburetors to choose from. Let's go into a little bit of my explicit opinion. If you got a small block and it's pretty mild, such as you kind of got maybe some headers on it, a small cam being like a 260 duration, advertised duration, maybe a 212 at 50 lift, right? Kind of a stock style intake manifold like the Edelbrock, just a performer intake manifold. And you've got a small block, 305, 318, 350, 360, 302, 351. A 600 will get you pretty much your daily driving, anything you want. And 600, 650, somewhere in there. The bigger engines, 351, 360, you might could go 700 in there and not get hurt too bad with a vacuum secondary. Again, my opinion right there. Now, once you start getting away from that camshaft size and you start putting different things in there, okay, now you got maybe a Victor intake manifold or a worked over air gap intake manifold. You've got some heads that are a little bit different. You've got aftermarket heads, or you did a really good job on porting your heads, stuff like that. That's going to completely change that, and it's honestly going to be trial and error to try to figure out exactly which one. And I know you probably don't want to hear that, but that's the way it is. Like what I was saying before, it doesn't matter how much you calculate this, you're not going to get that exact value. You got to put what the engine wants. Here's an example: ignition timing. How much timing does your engine want, right? How much initial ignition timing should you put on your engine? That's about as open-ended question as what size carburetor you want. That depends on the engine. This engine here is going to want something completely different than my 302 over there, which would be completely different than a slant 6 or who knows what. I had a 318 that wanted 16 initial and 20 mechanical, and it wanted more than that, but 91 octane fuel was a limiting factor to that. I think I might have bumped it to 18 degrees initial. Worked great. I put it at 14 and it was a dog. Well, there goes the whole, 32 degrees total timing right out the window there, because that would have been, 12 degrees initial and 20 degrees mechanical, right? Oh, I didn't mention big blocks. So in my personal opinion, kind of the same thing, a mild built big block, something like a 214 at 50 cam, I'm going to say 750 would get you there, right? It'll make it work, for sure. It'll work fine. It'll be street drivable. Is it going to be optimized? Now that is a completely different question. And I don't know, maybe we need to rephrase that question. What size carburetor does my vehicle need? Well, what's the optimal size carburetor is a pretty complicated question. Or what size do I need, or what type of carburetor do I need to just putt around and go on, the cruise nights and all that? Completely different question. Okay, let's talk about advanced setups. I'm glad New Guns Garage had this up there because, in my opinion, your mechanical secondary carburetors are an advanced setup. Your Holley carburetors are going to be a little bit more advanced than like your Edelbrock or your Quadrajet carburetors right there. I think there's a couple other ones that have the real simple setup on it, right? Where there's just a couple things you can adjust on there. Going away from that is going to be tunnel rams. And I'm glad he showed that on there because tunnel rams are a completely different animal right there on setting those carburetors up. Actually, you look at what the factory did. I know the Dodge stuff. So you had the 340s, 6-packs. I think that was... I'll put the number down there because I'm probably not going to say it right. But I think it's something like a 850 to like 950 CFM, something like that on a 340. And it wasn't spinning no 6,000 RPMs, and those things were beast. Then you had your big block stuff, 6-pack, those were even bigger. And of course you got thermoquads in there as well, with the ones with little bitty primaries and then just like big giant secondaries. So there's all kinds of different methods of going about that. But that 3, 4, 5, 6 number just, in my opinion, it's gonna get you too small of a carburetor. It'll get you where you want to go. I mean, like I said, you can run an engine on a lawnmower carburetor. Check out the card right there for that video. Not my video, Thunderhead Garage, his video. Good channel too, by the way. Okay, well, I think that's all I got right there. I appreciate you watching. I'll see you next time on Broken Tool Garage.